Hello, I'm Doga Cavdir from Stanford University. I will be presenting part of my dissertation project about movement-based music making, focusing on an aesthetics-based evaluation of a case study with a new digital musical instrument. I am in the final 2 years of my PhD program at Stanford's Center for Computer Research in Music and Acoustics. My research focuses on movement-based interaction design for digital musical interfaces. My two dissertation projects address accessible and inclusive musical instrument design and performance practices. File Sound project is an ASL-based MDMI. It is designed as an accessible instrument for deaf and hard-of-hearing listeners, and aims to deliver physical sensations of music through body movement and low-frequency, high-amplitude sounds. In this talk, I will focus on the Bodyharp project, which aims to bring the musicians and the movers' perspectives closer through movement interaction. As a verbal instrument, Bodyharp connects the musician's body and body movement to the instrument strings. It embodies both musical and dance-like gestures, expanding the gesture vocabulary of the musician and their use of space through larger-scale gestures. It encourages expressive body movements while keeping some familiar musical interaction. The first prototype of the instrument was played in an improvisational performance with dancers and other musicians. The interaction between the movements of the dancers and the Bodyharp's performer suggested to explore shared spaces between the perspectives of two artistic practices. Here are two excerpts from Bodyharp's performances. First one is improvised with dancers in 2018, and the second one is played by dancers as part of this user study in 2021. The last excerpt shows the composition and free movement improvisation steps of the user study. The study overall consists of 3 main parts. The first one is learning and practicing the instrument. The second one is the composition and movement improvisation step. And the third one is the questionnaires and semi-structured interviews. 20 participants joined the study from music, composition, dance, choreography, and other artistic backgrounds. Most of them reported to have a multidisciplinary artistic practices. The participants' experiences and performance tendencies varied based on their artistic backgrounds. While musicians focused on understanding the sound mapping and controlling the musical features, dancers performed in response to music generated through their movements with a more improvisational approach. Overall, both groups reported that the instrument encouraged them to move more and use their body movements to express musical ideas. They reported that the physicality of music making and the affordances of the instrument encouraged new compositional and choreographic ideas. In this study, we wanted to focus on the first-person experience of the performer and bring the musicians and the movers' perspectives and their experiences closer to each other. Both groups shared some elements of each other's artistic practices. The study's aesthetics-based evaluation included a qualitative analysis of users' self-reported experiences and a holistic assessment of the system and its affordances for a creative outcome. The participants' ability to create music and movement compositions showed the usability of the instrument for dancer-musician collaborations. We plan to conduct quantitative movement analysis using OpenPose for pose extraction and Laban movement analysis for movement quality computation. This future work will contribute to the design of movement-based musical instruments and offer more accessible and embodied performance practices. We will continue to explore its artistic directions in collaborative dance projects and with dancers and musicians with disabilities. Thank you for listening. For your questions, feel free to reach out to the author. Performance excerpts of the participants are available online.